Now that we kind of know the steps for a hypothesis test, let's look at a specific example. This will be about community college students and federal student loans. According to the Project on Student Debt, at least 1 million community college students, 1 in 10 nationally, do not have access to federal student loans, the safest, most affordable way to borrow for college. A new issue brief from the Project on Student Debt finds that almost a quarter of all community colleges do not participate in federal student loan programs, thereby forcing needy students to resort to riskier, more expensive options such as private student loans and credit cards. Is the proportion of community college students, the portion of community colleges that do not participate in federal student loan programs less than 25% as reported? Let's conduct a hypothesis test. So notice that they said less than 25. That'll be in our alternative hypothesis. The null hypothesis will probably say something about is equal to, because that's kind of the status quo. That's what's been thought to be true for a long time. But now we're starting to question it. That would be our alternative hypothesis. So, okay, let's first start by just stating what the null hypothesis is and the alternative hypothesis. The null hypothesis would be the proportion of community colleges that do not participate in federal student loan programs is 0.25. The alternative hypothesis would be the proportion of community colleges that do not participate in federal student loan programs is less than 0.25, because that was part of the statement. Now we'll collect data to test the null hypothesis. We're assuming, like we said, innocent until proven guilty. We'll assume the null hypothesis is true unless our research and our data say otherwise, and it maybe supports the alternative hypothesis, maybe not. For the purposes of this example, imagine that we select a random sample of 80 community colleges from the over 1,100 community colleges in the United States. Of the 80, suppose that 16 do not participate in federal student loan programs, so the sample proportion is 0.20. 16 divided by 80 would be 0.20. Okay. Because this sample proportion is less than 0.25, it provides evidence in favor of the alternative hypothesis. So it does seem like, based on this one sample, 0.20 is the proportion of community colleges, that do not have student loan programs. But we anticipate that samples will vary when the null hypothesis is true. How much of a difference will make us doubt the null hypothesis? So because 0.20 is smaller than what they stated, 0.25, but how are they far enough apart? Is 0.20 small enough to make me think that the null hypothesis can't be right? Do we have evidence strong enough to reject the null hypothesis and accept the alternative hypothesis? Well, now our third step would be we're going to assess the evidence. To assess the evidence, we need to know how much variability to expect in random samples when the null hypothesis is true. And we'll see how to do that later in the coming modules. We begin with the assumption that the null hypothesis is true. In this case, we assume that 25% of community colleges do not participate in federal loan programs. We then determine how unusual the results of the sample are. We ask, if the proportion of all community colleges without federal student loan programs is 0.25, what is the chance that a proportion of the random sample of 80 community colleges is 0.20 or less? Obviously, this probability depends on how much variability exists in the random samples of this size from the population. So we'd have to know a little bit more about statistics and a little bit more information about these community colleges and how much variability there is within them. The probability of observing a sample proportion at least this small, if the population proportion is 0.25, is approximately 0.15. Like we said, upcoming topics explain how to calculate this probability. This is the p-value. So in our example, p is 0.15. It tells us that if the population proportion is actually 0.25, we will see a sample proportion of 0.20 or less about 15% of the time, because that's 0.15 in percent form. Note that the p-value is a conditional probability. The condition is the assumption that the null hypothesis is true. So someone came up with this p-value of 15% or 0.15 based on assuming that 25% or the proportion of 0.25 of community colleges actually have a federal student loan program. Okay, based on that, let's come to a conclusion here. The conclusion, note that the p-value is fairly large, so it's not surprising to see a sample proportion of 0.20 or lower if the population proportion is 0.25. If we use a significance level of 0.05, like we said is pretty common, the p-value is larger than 0.05. So the difference we observe between the sample proportion and the assumed population proportion is not statistically significant. Differences this large can be explained by chance. We might have happened to have chosen 80 of the 1,100 community colleges that happen to have a higher proportion of the no federal student loan programs, more so than the overall population. In this case, we'll fail to reject the null hypothesis. Here's our conclusion stated. The data do not provide significant evidence that the proportion of community college students without federal student loan programs is less than 25%. But notice that the conclusion answers our original research question. It focuses on the claim that is in the alternative hypothesis. It does not say, quote unquote, the null hypothesis is true. We never accept the null hypothesis or state that it is true. When there is not enough evidence to reject the null hypothesis, the conclusion will say, in essence, there is not enough evidence to support the alternative. So we're not saying we're supporting the null, but we're saying that we're going to reject the alternative, and there's not enough evidence to support it. Now here's our summary. We've seen 2 hypothesis tests at this point, so let's summarize the steps. First, we determine our hypotheses, use the research question to form null and alternative hypotheses about a population parameter. The null hypothesis says there is no change. Then we, second, collect data, which we did, well, I guess we talked about, someone else did it. Collect a random sample from the population, summarize data with a statistic, like the proportion of how many 16 out of the 80 community colleges that we sampled had federal student loan programs, or sorry, didn't have federal student loan programs. And then third, we assess the evidence, determine the p-value, like we'll learn how to do in the future. If the null hypothesis is true, how unlikely is it to observe data like those obtained in the previous step? And then the fourth step would be state our conclusion. Compare the p-value to a significance level. Usually the significance level is 0.05. So if your p-value is less than or equal to the significance level, we reject the null hypothesis and accept the alternative hypothesis. But alternatively, as in the example above, if the p-value is larger than the significance level, like ours, I think our p-value is 0.15 and the significance level is 0.05, we fail to reject the null hypothesis. There is not enough evidence to accept the alternative hypothesis.